Okay, so welcome back. Next up, we shall create a header which we will use for encoding and encrypting as well. Now, you might find this way of encrypting things a bit strange, odd, and weird, to be honest, because we are going to use base 64, and base 64 is not really an encryption, it is an encoding procedure. So, in order to do that, for us to encrypt, we will need to add some of our own things into it. We will add salts. Basically, let's say that they're called keys that we will put in there, and you will need those exact same keys later on to actually decrypt it. You will see what I mean by it. Basically, what will happen is that we will do a single base 64 encoding, and then we will add salts. We will add characters to that particular encoding, and then we will encode it again with those strings in it. Then once again, we will add strings and encode it again. The procedure will run through 3 times, so anybody who wants to actually decrypt it with base 64 go through the decoding process, they won't be able, because it won't be valid base 64 without the additional keys, without which it will be extremely difficult to actually decrypt this. Some of you might ask me, well, why do you not use the industry standard encryption IS and so on and so forth? Well, I mean, I don't own rights to IS or anything like that, and plus, if you use IS, you will need some additional libraries, which is a problem, because external libraries will probably call for installation, and we just need an exe file, which we can run, not something that goes through an installation procedure. Henceforth, this encryption method is here for you, and we'll see how it goes. Feel free to try to decrypt it. If anybody out there is good with this, feel free to try to bust it. And if you manage to do it, please do let me know and tell me how it went. Share your experience. I would be most grateful. Anyway, as before, let's go ahead and create a new header. So I just need an empty file. Yes, please. This one will be called base 64.h, and we'll just go ahead and save it. Okay, let's zoom it in. So this is basically the 4th file we have created thus far. Ooh, exciting. Let's go ahead and create our guards. So if and def, if not defined, base underline 64, and down below we're gonna get endif, but before that we need define base 64 underline h, and I am a genius as usual. Base underline 60. Right. Okay, so base 64 underline h. There we go. So now it is properly set and functional, and all is well and fine and dandy and whatever and whatnot. So let's go ahead and type in include vector and include string. Okay, so string we have seen before, but vector, this is basically a data structure that is fairly similar to an array, but is far more flexible and is far more dynamic. It can be changed, modified, things can be placed, pushed, etc. A lot of things can be done with it. Now, let me just go ahead and attempt to explain base 64 algorithm. I would strongly recommend, strongly advise you to go onto the net and take a look at how base 64 actually works and the proper explanations for base 64, because I'm just explaining it from previous experiences and from the way it was used, from the way I've used it in this particular example. But I strongly advise you to go onto the net and to read more in this regard. So We'll use base64 algorithm to encode and decode strings. We will together make a program which will be capable of decoding this encryption on the other end. So this is a relatively simple algorithm. These are some of the fundamentals of that algorithm. Base64 algorithm transfers bytes to human-readable string, which consists of characters from A to Z, lowercase, from A to Z, uppercase, and digits from 0 to 9. They fill 62 characters out of 64. Additionally, algorithm may use plus and slash characters for indexes. 62 and 63, those would be plus and slash, because indexing for base64 starts at 0. So you do have 64, the length is indeed 64, but when you begin from 0, you go up to 63, and that's 64. These characters differ from standard to standard, which is, to put it mildly, a pain, but yeah. But we'll use plus and slash in this particular, in our example for our needs. Also, there is a mandatory padding character, which is equal sign. This is used to label encoded string for padding, so that the decoder knows that info when decoding that particular string. All characters are printable, and every other character or byte can be represented in only base64 characters. Now keep in mind that this is doable, that this is possible. They can be transferred via mail without any loss of data, which is extremely important for us. We do not wish to use any sort of compression, encryption, encoding methods which will cause the loss of data, because then this entire endeavor is rather pointless. So let me just drag my screen from my other virtual machine into the recording area. Or I can't, yeah, let me just, come on. No. This is amazing. Purely amazing. It won't exit full screen for some strange reason. Let's see what the problem is. Okay, apologies for the technical difficulties that we have experienced. I've just minimized the machine so that I can drag another screen over. So this is my other virtual machine, which is a Linux virtual machine. Far superior to the Windows one. Anyway, this is where I keep my files open, the project and all that. So you can see that there are a lot of other header files that we will need to make and construct. But for the time being, I wanted you to take a look at the algorithm base64 table, how it actually looks like. So obviously, this is not the entire table, but this is how it looks like. You can see that the indexing begins at 0. So with 0, A 0, B is 1. So this is the character, and this is the code for the character. So A is 0, B is 1, C is 2, etc. And so on and so forth, all the way up to 63. So from 0 to 63, that's 64 codes. So here are my notes as well. I might as well read from them a bit. So there's an example that I found on Wikipedia, and the word man is encoded as TWFU. How does this work? Well, the first thing that happens is that the ASCII values of the character M, A, and N are taken. These are M is 77, A is 97, N is 110. You can take a look at the ASCII table on the net. I strongly advise you to take a look at that too. It's very convenient. And these are the binary representations of these numbers. These are 8-bit representations. So it's like 1, 2, 3, 4, 5, 6, 7, 8. Yep, these are 8-bit representations. Let's scroll down a little bit. Then all the binary digits, they are grouped, so it looks like this. It's just a very, very long string of zeros and ones. Length in this case is, of course, 3 times 8, which is 24. So 24 bits are grouped into groups of 6 bits. Why 6? Why? Well, take a look down below. Because 2 to the power of 6 is 64. Hence, base 64. So we can map them to our table. you can see how the grouping is done rather easily. So every group is 6 digits. 6. These are 8. Look, each one of these is 8. 8, 8, 8. And here, once those all 8s are combined, it's 24. And now you split 24 into groups of 6. So you have 6, 6, 6, 6. And then you convert them to decimals again. So now it's 19, 22, 5, 46. Completely different from this above, from what you see above. And if we map these to our table, they will to the base 64 table, they will equal 19 will be T, 22 will be W, 5 will be F, and 46 will be U. That's what, hence you get the encoded version. It's DWFU. But this is not encrypted by any measure or means. This can be decoded online for free in a matter of moments. So that's not a big deal. Now, enough of that. The code itself is down below. I usually keep it up here open while I'm doing this for you. But our algorithm, keep in mind on this. This is important for us because this is what has been done in our example for our base 64 encoding. Not our base 64 encoding, but for this example. Not the Wikipedia anything. Like this is separate from that. So our algorithm will directly encode string to string. But minor modifications are needed to encode arbitrary byte sequences. And these arbitrary byte sequences are what we will use to obscure base 64 and make it unreadable and undecodable. Okay, so let me just go ahead and move this to the other screen, out of sight and out of mind. And we can actually begin to code. I hope that I've made at least somewhat of a good explanation in regard to the base 64. I'm sorry that I've taken so much time. I know it must be boring and that you want to jump straight into code, but believe me, it is something that is important. It is something that you should be able to understand. Anyway, I bid you farewell, and we'll actually begin to code in the follow-up tutorial.